A very good morning to all of you. I hope all of you are doing well and completing all the works related to your studies. In the last class, we discussed about relations topic, its types, and most importantly, the problems related to equivalence relations. Now, as the topic name is relations and functions. So for today class and for upcoming classes, we are going to discuss about the topic functions. Now we all know that relations or relation is the Cartesian product subset. Suppose we have two sets, A cross B is the Cartesian product of two sets and their subset is called the relation. Now any relation is called function if every element of A must have only one and only one image in B. That is, a relation from A to B is said to be a function if every element of B has one and only one image in B. That is, for each element of A there should be one image in B. If this condition happens for a relation, then that particular relation is called a function. Now the value of A is called the domain and the value of B is called the range. It is also sometimes called codomain. Now as we are seeing a mapping here, for A we get the value 1, for B we get the value 2 and so on. So this type of relation in which every element of A has one and only one image in B is called a functions. Now this representation is like this, f such that A to B, where A is the domain and B is the range. Now any two functions f and g are equal if the domain of both are equal, the codomain of both are equal, and the value, the range that we are getting after substituting the value of x must be equal. So in short, relation is the subset of the Cartesian product and any relation is called function if for every element of A there must be one image of B. There must be one and only one image of B. Then that particular relation is called a function. So by this example we will able to understand what a function means. Now in this topic we have to discuss about many types of functions. One, onto, many one, injective, surjective, bijective and their compositions. So in the next video I am going to tell you about the types of functions. So now we are going to discuss about types of functions. So to understand the type of function I have drawn some mapping diagrams here. We have two sets x and y which are related to each other. So the function here goes from x to y. Now if every element of x has an image in y, just like 1 is related to A, 2 is related to B, 3 is related to D and 4 is related to C. So every element of x has an image in y. So this is called 1, function, which is also called injective in nature. If every element of x has an image in y. Now if two elements have the same image in y, that is 1, 2 are related to B only, that type of function is called many-one function. In this, one-to-one relation is there. Every student have only one roll number. Every student has a unique roll number. That is a 1, function. Now, if both two are related to the same category, same image, they are called many-one function. Now, if every element of y is considered as the image, just like in both cases we are seeing that some parts are left out, but in this all three are covered. So if every element of y is the image of element of x, that is called onto function, and this is also called surjective in nature. If we combine both, that is every element has a unique image and all the elements of y must be covered under the image. So that type of function is called bijective, means satisfying both 1, and onto. So by understanding all these type of function, we understand that if every element has a unique image, that is 1, 1. If more than two elements have the same image or two elements have the same image, that is many-one. If every element of y is the image of element of x, no element of y should be left out, that is onto. And if 1, and onto are satisfied together, that is called bijective function. Injective plus surjective means bijective. So I hope you understand all the types of functions. Now in the next video I am going to tell you about the composition of function, that is fog, gov, fof, gog.